Hello students, welcome to this video. Let's solve this question which was asked in 2018 for 4 marks. The question is from chapter triangle. In an equilateral triangle ABCD is a point on side BC such that BD is equal to 1/3 of BC. So we have to prove that 9 times AD square is equal to 7 times AB square. This question is based on application of Pythagoras theorem, but recently this topic is not included in the NCERT. But we are solving this question because it's been asked for so many times. So just look at the diagram. ABC is an equilateral triangle. So AB is equal to BC equal to AC. So and D is any point on the side BC such that BD is 1/3 of full BC. So what I have written and given is triangle ABC is an equilateral triangle. BD is 1/3 of BC. To show that 9 times AD square is equal to 7 times AB square. This is our target. So what I have constructed in this question is I have drawn AM perpendicular to BC. And then I have joined AD. Now we know that in equilateral triangle the height always bisects the base. We can prove this by showing the two triangles congruent, but I am assuming this thing is directly. So AM is perpendicular bisector of BC. So which implies BM is equal to MC. So this BM is equal to MC. M is midpoint, or we can say that BM is half of BC. Similarly, CM or this MC is also half of full BC. This is what I have written over here. In reverse manner, we can say that BC is the double of BM or double of MC. So I have given this equation label 1. Okay. Also, it is given that BD is 1/3 of BC. So this implies BC is 3 times BD. This is my equation number 2. And this is a small calculation showing that this is 1/3 of BC. So this is one part and this is the two parts, okay, because this full part BC is 3. Out of 3 this is 1, so remaining will be 2. So what I have said is proved by these 2 or 3 lines. So BD is equal to BC upon 3. So from this I can write BD upon BC is equal to 1/3. So this ratio, this means that BD is equal to 1m. M is common multiple. BC is 3m. Now what is DC? You can check into the diagram. What is DC? DC is full BC minus BD. So that's what I have written. BC minus BD. Now what is BC? BC is 3m minus 1m, so 2m. So the ratio of DC over full length BC is 2/3. So DC is 2/3 of BC. I have given label number 3. So we have to remember these 3 equations till the end. So they are very useful equations. I am going to use them in the end of the solution. Let's move further. Now in triangle ADM, so ADM, so this triangle, so what I am doing here, I am using Pythagoras theorem. In triangle ADM, by using Pythagoras theorem, hypotenuse square is equal to the sum of squares of other two sides. And from this equation I have kept AM square on one side. So this is going on, this is on this side, and sorry, this thing is moving on this side. Okay, so AM is equal to AD square minus DM square. Same thing I'm going to do in triangle ABM. Where is ABM? ABM. So AB is my hypotenuse, AM and BM are the two sides. So in triangle ABM, by using Pythagoras theorem, I have hypotenuse AB square is equal to sum of squares of other two sides, AM and BM. So again, from this equation, I have kept AM square on one side. So this gone on that side. Now this is my equation 4 and this is my equation 5. In both equation, I have AM square on one side. So this implies their RHS will be equal. From 4 and 5, we have AD square minus DM square equal to AB square minus BM square. So from here, our solution, the main matter of the solution starts. So we have to adjust few things over here. Now, what I'm going to keep, AD square I'll keep on this side. AD square equals to AB square, and this is going on that side. So plus DM square minus BM square. Now, you have to do some calculation or experiment over here, so that you will know what you have to do or what you have to reject. So what I have tried is I have substituted BM over here, and I noticed that nothing is giving me a useful answer. Then I tried substituting DM by like this, BM minus BD. Then again it was a failure. Then I thought, let's substitute this DM by subtracting MC from DC. Okay, so this DM is equal to full DC, this full DC minus this MC. So this gives me the required answer. So anyhow, you have to do this experiment by your own. Okay, then only you will know that there's only one substitution which is going to lead you to the answer. Now, I'm not going to disturb this AD square and AB square. Why? Because just look at the proof. What we have to show is AD square and AB square. They're already there. Okay, I just need to adjust this 9 and this 7. Okay, so AD square, what I have planned is I am going to replace this DM. So I am put DM equals to what? DC minus MC. But we have DM square. Okay, so AD square equals to AB square plus instead of DM, DC minus MC square minus BM square. So AD square as it is, AB square as it is. This is recognized as A minus B whole square. So DC square minus 2 times DC into MC plus MC square minus BM square. So BM and MC, they both are equal. Okay, BM is equal to MC, so their squares will also be equal. So they are cancelling over here. They are cancelling each other in the end. Okay, so AD square equal to AB square plus DC square minus 2 times DC into MC. So what reason we are going to give over here is, since MC is equal to BM. So it is gone. Now DC. So what I have to change over here is okay. Now MC is this MC is 2 times BC. Okay, this MC is 2 times BC. Now what is this DC? I want to replace this DC by some other value, maybe BC. Look at this third equation. DC is equal to 2/3 of BC. Okay, DC is equal to 2/3 of BC. So I'm going to use these two equations here. Okay, AD square as it is, AB square plus, instead of DC I have to write 2/3 of BC, but there's a square. So this will be 4 by 9 BC square minus 2 times, what is DC? DC is 2/3 of BC, and what is MC? MC is 2 times BC. Okay. So AD square, AB square plus 4 by 9 BC square, and this is, let's check it again. So 2 is over here, DC is 2/3 of BC, and instead of MC I have to write 2 times BC. Okay, negative of 8 times BC square upon 3. So AD square is equal to, now so let's clear this. I'm sorry, there's a correction. This MC, instead of this MC is half of BC. So what I was writing is MC is equal to 2 times of BC, which was incorrect. So this term is giving me some absurd answer. Okay, so 2 is correct, DC is correct. Instead of this MC, what I have to write is BC upon 2. So this 2 and this 2 cancels. What I have is 2 times BC square upon 3. Okay, now we are on the correct track. So okay, this happens from 2 and 3. 2 and 3. Also observe that triangle ABC is an equilateral triangle. So what we have, AB equals to BC equals to AC. All three sides are equal. So I'm going to replace this BC by AB. Okay, AB square plus 4. This BC is gone, and instead of BC it is AB square upon 9 minus 2 AB square upon 3. What is the reason for this? Equilateral triangle. Okay. Now there is 1 in the denominator, so we have to take the LCM. AD square. So LCM will this will be 9AB square plus 4B square minus, to make this 9 I need to multiply this by 3 and this is by 3. So this is 6AB square upon 9. This 9 is cross multiplied on that side, so this will be 9AD square. Now simplify this. This is 9 minus 6, 3 plus 3 and plus 4, so 7AB square, which is the required answer. I hope you have understood this adjustment. Please give a try over here. You have to work on this, okay? Then only you will be able to solve this by your own. So this is the solution for this question. Thank you, everyone.